How's everyone doing today? Y'all doing good? So, as many of you have probably seen recently, you've probably gotten like a call, a robocall that has like your area code on it. Well, that's a strategy that bad actors in these scams are using to get to consumers, and consumers are sadly falling victim to that, which is why the FCC introduced Stir Shaken. And with me today, I got these two gentlemen who are experts in the industry. I got Alan Percy of TelcoBridges and Jim Dalton of TransNexus, and they're gonna go more into what Stir Shaken means for our world. All right, guys.
Well, thank you, Greg. Thanks everyone for joining. Thanks, Jim, for joining me. And Jim and I have been collaborating quite a bit over the last couple of years on this challenge. So we're going to hopefully share a little insight. We'll talk about sort of where the industry is going, what's left to do, which there's still lots to do. And we'll show you some charts and some figures. And then hopefully we get towards the end, it'll turn into a dialogue. We look forward to hearing your questions and maybe your thoughts. Maybe experiences, if you had some firsthand experiences. I'd love to hear all that. So let's ask an important first question. What am I doing wrong here? Oops. The on button makes a big difference. Let's try that. No? All right, I'm going to ask you to advance for me. If you could advance. All right, so again, I'm Alan Percy. I'm the CMO for TelcoBridges. We're a developer of media gateways and session border controller technology used in the core of many of the service providers around the world. We've sold to about 100 countries around the world with our equipment, and it's a key piece of implementing the Stir Shaken implementation for a lot of service providers. And Jim, you want to introduce yourself?
Alan, you caught me sleeping. Thank you. Yeah. So, Alan, thank you for arranging all this and waking me up after lunch. So, just a little bit about TransNexus. We're a software provider, and one of the solutions we provide for service providers is Stir Shaken, so we know a lot about it. And we work closely with TelcoBridges because, one of the key kind of integration challenges for a lot of networks is getting the Shaken passport, that digital information, into the call signaling. And maybe you've got a TDM network that converts calls to SIP, or maybe you need an SBC, but either one of those is a mechanism to get that digital signature, that is really what Shaken's all about, into the call signaling flow, the SIP call signaling flow. And so we work with TelcoBridges because they make that really easy for our customers, whether they have SIP networks or TDM networks. And one thing we'll talk about that's really kind of interesting is a new standard that's actually been two that have been out there for about 2 years for one of them, for implementing Shaken over TDM networks. And again, TelcoBridges has been way ahead of everybody else of making that possible to do Shaken over ISO. Everybody thought that was impossible, but it can be done. And so anyway, that's how we know TelcoBridges, because they've really given out a lot of solutions to a lot of our different customers that needed a way to figure out to get this Shaken to work on their network, because there are really no other solutions available. So anyway,
Awesome. So I'd like to learn about our audience here too. So quick show of hands here. How many of you are with service providers? Okay, handful. Enterprises? Any enterprises here? Okay, implementers, integrators, distributors. Just wandered in off the street and not sure you were here for the free lunch? All right, half the crew. All right, very good. All right, let's go on to the next slide. So we have a question for you. What is it going to take, right, to stop the robocalls? And I'll tell you a little bit of the backstory on this. Is every once in a while I'll go someplace for lunch or for dinner and meet a new group of people, and they'll say, "Oh, so Alan, what do you do?" I said, "Well, do marketing for a telecommunications company." "Oh yeah, like what? I mean, do you sell cell phones, or what do you do?" And it's like, "Well, no, we make the equipment that goes inside the network to protect the network and stop robocalls." That usually triggers a very strong response. what are you guys going to do to stop those robocalls? And then, of course, I get a whole earful of how a grandmother or a mother-in-law or somebody got ripped off with an illegal scam over with a bunch of gift cards. And so it all was a little bit distant. And then I found out that I would call it my wife's mother-in-law got ripped off for some $8,000 of Apple cards. It's like, ooh, it's personal now.
I didn't know that. My dad got his Social Security number stolen from a scammer.
No way.
Calling
Really?
Yeah. So I didn't know that. I'm sorry to hear that.
Yeah. Oh no.
Anyway, it does happen.
It's personal pain, right? Beyond just the phone ringing and them asking, "We've been trying to reach you," right? So anyway, let's go to the next slide. So the FTC reported there's been some $10 billion a year in crime due to that, and the FCC thinks that there's some $3 billion a year in just wasted time. And Jim and I did a little analysis with some of our customers a couple years ago. Just think about a contact center, inbound contact center. Their lines and trunks get tied up with these bogus illegal robocalls. When they just randomly dial numbers, they run into businesses and waste people's time answering them, let alone you as a consumer waste your time. So all very wasteful and huge demand on the network too. So next slide. So let's just talk for a second about life before stir shaking. So let's get in a little time machine, skip back maybe 10 years. If you could give me an advance. So why did they start doing it? Well, first of all, as I'll show you here in a second, it took very low-cost infrastructure. And they now can, with the invention of voice over IP, you can make telephone calls, especially these really short telephone calls, for virtually $0. I mean, it's very easy to make a lot of phone calls and not spend any money. It's really easy. It was real easy to hide your identity, so it was really hard to find where the calls were coming from. The whole operation can easily be operated overseas. You can set up a cloud-based IPPBX or a cloud-based Astra system in Amazon here in North America, but you're sitting somewhere else, anywhere else, right? It could be India, it could be Pakistan, it could be the Philippines, it could be anywhere, and you can operate it remotely. And frankly, Americans, we're a pretty trusting crowd. We'll answer the phone. We used to answer the phone anytime. Remember that? The phone ring, you'd rush to answer it. Anyway, and with the right scam, it's very easy. You can have a very highly effective, and of course, that's why some of these have repeated themselves, right? It's Social Security calling because your Social Security ID is turned up someplace, or what's one of the other good ones besides the extended warranty? I mean, there's plenty of these
IRS scam.
The IRS
huge.
scam. Yeah, huge. Okay, next. And I know my graphic might have gotten a little goofed up here, but you used to be able to stand up an Astra server and with some scripts and some prompts, you connect up with a SIP trunking provider on the upper right, and you could make millions of phone calls in a matter of hours. It was took a little bit of technology experience, but you could do it pretty easily. And you could spoof every one of those numbers. So they looked like they came from your neighbor, or they looked like they came from your general area code. Was very, very easy to do. And there was like literally zero risk of getting caught. So guess what? They did it, and they did it, and they did it, and they did it, right? And if you remember, 7 or 8 years ago, it was just getting out of control. So, okay, can we go next? All right, so why is stir shaking? Where did this come from? What's the purpose of it? And I promise you this will not be a tutorial on a full stir shaking. By the way, who here thinks they know stir shaking? A handful of you, that's good. All right, let's go on. All right, so let's just talk, the challenges that that stir shaking was facing and why they implemented it. So first of all, it was so easy to spoof a caller ID. It was very, very, very easy. I mean, you literally, when you made a call, you provided the calling number, and that's what showed up on the destination phone, is the calling number. So it was very easy on a SIP trunk to do that. Those calls often traverse through many intermediate service providers, which makes it really, really hard to figure out where it originally came from. And then also, it was really, really hard to put together a court case to go after somebody, because these calls because they traversed so many service providers, it was hard to find where they really came from and then prove it in a court of law. So the goal of stir shaking really boiled down to three things. One of them is to secure that calling party information so that you knew when it got to the destination that it was actually the originating caller information, and also to leave some breadcrumbs through the network so that you could figure out who the source of the call originally was, and then simplify the traceback mechanism so that if there was illegal traffic, you could quickly go back to the origin of that traffic and shut it off. So those are the three goals of stir shaking as they originally were laid out. If you go to the next slide, I've created an oversimplification. I think you have to hit advance a couple more times. One more time. There we go. All right, so a super simplification of stir shaking is that the originating service provider is going to attest, and you'll hear that word attestation a bunch. They will attest to the fact that they know who this customer is, and they can guarantee that this is indeed one of my customers, and I know the calling party. And they're going to create this token, as Jim just mentioned a few minutes ago, and bury it into the signaling of the call, pass that through a secure link through the intermediate service provider so that the terminating service provider now can open up that token, verify that it has been not molested in the process as it was traversed, and then verify that that caller information is indeed correct and deliver it to the destination called party and know that it has not been manipulated. So far, so good? It's pretty, at the very, very high level, it seems pretty straightforward, but it's critical to understand that stir shaking's main job is calling party information goes through the network and is authenticated and attested to so that the destination party knows for sure where it came from. I probably super oversimplified it, didn't I?
That was good.
Okay, let's go on next. So a little timeline of where stir shaking came from. I think you all remember, right, when we had the Do Not Call Act, which basically was where we published it was like giving away all your passwords. It's like, oh, here's a phone number that I use, you should call it. It completely backfired in the beginning because the bad guys didn't care about the Do Not Call list. They used it as their source of telephone numbers to call. So anyway, the Truth in Caller ID Act got passed. We're talking, 2009, 2019, the FCC finally calls for stir shaking implementation. There's some folks that we've worked with over the years have put a lot of blood and sweat into the implementation or the specification of stir shaking. The big one was probably the TRACE Act, and Jim, maybe just you could jump in real quick, just talk about the TRACE Act and why that was so important.
Yeah, the TRACE Act is really what drives all of this in the U.S., and that kind of helped things spill over into Canada a bit. And also, by the way, shaking is occurring in France. They've had a similar type legislation in France. But what the TRACE Act is, it gives the FCC, or rather requires the FCC to enforce all telephone service providers to implement the shaken standard on their SIP networks and to also implement a call authentication mechanism on non-IP networks. So it's the mandates that are required. The idea of shaking is a great idea. Everybody loves the idea, but nobody wants to do it first. It takes a mandate. Everybody has to do it because, the laggards get a free ride, so you've got to make everybody do it at the same time to get the benefit. We're not there yet, but the mandate has occurred and shaking is starting to be deployed in the network based on the TRACE Act.
So then there was a couple of milestones after that, right? The FCC mandated stir shaking be implemented first on IP networks, and that was in June of 2021. And hopefully after that, we started to see a difference in behavior of the illegal traffic. One other element with that was that you may not accept, which was the idea is that the service providers now had the option of denying traffic that would enter into the network that looked faulty or didn't pass. And more recently, there was a triennial report on stir shaken, basically asking the service provider community, did you find this technology is working? And the general consensus I know you did analysis on it too, was that it's effective at doing what it's supposed to do, but we'll get into what it doesn't do in just a couple of minutes here.
Can I make a comment about the timeline?
Yeah, go ahead.
So this is a great timeline, by the way. I want to add one more box, Alan. I think it's really interesting. So you've got June 30th, 2021. That's when the big carriers in the U.S., more than 100,000 subscribers, had to implement Shaken on their SIP networks. And the FCC said if you're a small operator, you've got 2 years until June of 2023 to implement Shaken. And then they went back and they changed their mind. And I was going to suggest there should be another box up there for June 30th of 2022. And what I'm going to mention is that mandated deadline applied to all small service providers, less than 100,000 lines, that use SIP as their for providing telephone services. And what's really interesting about this, what came out, I did not foresee this when the FCC wrote the rules, but what is important about Shaken, it's not just that you have a SIP network. It's the two key phrases are you have to know your customer and you have to police your network. And the entity that's responsible for implementing Shaken is the originating service provider, the service provider that serves the end user. And a whole group of people who are here at this show got caught up into Shaken who never imagined it. And those are MSPs. And we got calls from MSPs in a panic. They literally had no network. They had no network. They did have a data center, but what they did is, for their own gear, but what their business was, well, we manage 100 Astra servers for our customers. And those Astra servers are on our customer's premise. We don't have a network, and we like that because our network can't go down. And they would configure those Astra servers to send their voice over IP calls directly to pick your internet voice over IP service provider. I'm sure there's some here, the intermediate providers that would carry that call out to the rest of the world. And those MSPs, they were the originating service provider because they knew the customer. They billed the customer. If their customer had a phone problem, they called their MSP. They didn't call VoIP Innovations or Bandwidth. They called their MSP. That MSP, with literally no voice network, had to implement Shaken. They had to buy Shaken certificates and sign those calls for their customers. And it's interesting. I mean, they were running Asterisk, didn't support Shaken. 3CX doesn't support Shaken. PBXs typically don't support Shaken, so they had to improvise and do some things to enable Shaken for calls that their customers originated that get put onto the telephone network, even though they didn't have a network. I think that's, that's one of those funny things that nobody foresaw, but came out of, the rules that the FCC wrote. And anyway, so I know there are a lot of MSPs here. I just wanted to say, they were remarkable how quickly they responded. They're light, they're nimble, they can do anything. I mean, they're kind of computer guys, and how quickly they responded to their mandate being shortened from 2023 to 2022, and they only had about 6 months to get the work done. Yep. So anyway, sorry to digress.
No, that was good.
I think that's an amazing piece of this timeline I wanted to add.
Yep, no, it's a good point, good point. And there's a lot of other baby steps. And one of the other ones that's coming up is that the FCC's got laid out the STIR-SHAKEN has to be implemented by all service providers by June 30th of this year. Now that's a particular challenge for a lot of the smaller and the rural operators. A lot of them, have gotten a pass for a couple of years while they figure out how they're going to implement it. But as Jim and I were talking about over lunch, some of these service providers, they're co-ops. They're not big, wealthy, deep pocket service providers. They got to go back to their members and some of those kind of smaller organizations to get their funding to be able to implement some of this. So you'll see the impact of that here. Okay, next slide. All right, so why do we still get the illegal robocalls, spoofed calls, right? We implemented all this. Most of the big service providers have implemented it, and there's a mandate to finish it up. So why are we still getting them? So now we're going to talk about some data. So this first chart here, this is from our friends at UMail, and they track through their mobile app, the amount of or kinds and types of different illegal robocalls that come in through their network. And they have a great blog that reports some of the figures over the last couple of years. And you can see there was a little dip back in February 20, but it roared back in. Now it's obviously well away from being zero. And in their blog, they kind of comment, the economics of being an illegal robocall are still very, very compelling. And the enforcement actions are hitting some of the carriers where it hurts, but the traffic just seems to move to other carriers. And I think that's a key piece of what we're learning now, is that, you lock the front door, you lock the back door, but guess what? The side door wasn't locked, and they're getting into the network. And that's one of the, the issues with security, right? All the doors have to be locked. And as we just talked about in the timeline, there's still some doors that are open. So next slide. This is from Jim's company. He's got some metrics on it. So Jim, I'm going to let you talk about some of these here.
Yeah, so this is interesting. We have got over 100, maybe 200 customers who they use our cloud solution to shake and verify their calls. So we have a lot of data that we look at to see, what's going on out there in terms of robocalls that our customers are seeing and how many calls are being signed. And you can see, there are a lot of robocalls that are being signed with shaken passports. And what's really kind of disturbing, a robocall with a sign of an attestation of C, that makes sense. And let me back up for a minute and define what attestation means. And let me digress a little bit before I get into the details of this. When you're originating service provider, we talked about you need to know your customer and police your network. And your responsibility is, do you trust the calling number that you're going to send out the public switch telephone network? And if it's a number that, you've assigned to your customer, it's hosted on your PBX, that telephone number is tied to a specific handset, you can give that call a passport, a shaken passport with an attestation A. And that gets carried through the network, and what's verified at the far end, that terminating operator will see, okay, this telephone number, it hadn't been spoofed. Here's a company, they've put their digital signature on it, that this is attestation A. If there's a problem with this phone call, the feds know exactly who to go to, what telephone company enabled this scam call. So that's really kind of one of the key pieces of integrity and shaken, is it really enables enforcement and accountability. So robocalls with attestation A, how is that happening? And I guess they're coming in the side door, perhaps, like, Alan mentioned, it's hard to say for sure, but maybe more troubling are calls with attestation B. And what does that mean? That means you trust the trunk, but you're not sure about the telephone number. It's partial attestation. So you know what trunk that came from. And so attestation B really doesn't mean much, but look at the volume. A quarter of all calls with attestation B are robocalls. And I think what we are seeing here is kind of the side door that Alan referred to, is there are a lot of intermediate providers. These are wholesale providers. They're not originating service providers, so they don't know the end user. They are selling shaken. They are signing calls on behalf of other telephone companies, service providers that could be serving call centers, who knows where. The end user is the problem. And there's a service provider that is getting shaken services from an intermediate provider who is signing those calls on their behalf. And that intermediate provider doesn't really know the customer. They just know, hey, I know this is a service provider over here. It looks like an enterprise. I'm going to give them an attestation B because I trust that trunk that they're sending these calls on. And that's kind of a free pass. I'm doing shaken. I'm not doing shaken, with gateway attestation C, which means there's no trust. I'm doing shaken. Attestation B, that's good enough. But it really isn't. The result is we're getting a lot of robocalls that are assigned, and they're robocalls. They're problem calls. And the real lack of enforcement here is they're not being signed by the originating service provider. They're being signed by an intermediate provider that's once removed from the originating service provider. And that's really the side door, Alan, that lets a lot of these robocalls into the network. Yeah. So anyway, I guess Alan's point is, there's still a lot of robocalls in the network, except what's gotten worse is now a lot of them are being signed with shaken passports.
Yeah, once you advance. So this is another one from one of your blog, and the idea is that the shaken participation over the last 2 years had risen significantly over the last 2 years, and more recently, this last year, it's kind of leveled off, right? That there's not a lot of new service providers that are implementing shaken. That we've maybe saturated. Maybe is probably a way to put it.
We don't think so.
No?
Not even close. So there is a database that the FCC has put out there. They require every service provider to certify their robocall mitigation plan. So if you want to be able to accept telephone calls from another service provider, you have to be in this robocall mitigation database. The way the FCC enforces that, if you're a telephone service provider and you're going to receive calls from another service provider, they have to be in that database, or you're required by the FCC to block those calls. So everybody has a robocall mitigation plan in the database to certify either we're doing shaken or we have a robocall mitigation plan. There's 7,000 companies in that robocall mitigation database. Now, a lot of those are double counting. There's some holding companies that have multiple small operators beneath their filing. So there can be multiple robocall mitigation filings that are really, part of a much bigger company. But when you take those out, there's still over 5,000 U.S. service providers, and there are also some international providers in there as well, that are originating telephone calls. And that's nowhere near this number of shaken companies who are authorized to implement shaken. This is the number of companies that are signing with their own certificate. So what gives? We think it's the intermediate providers that are signing calls for all those people who have filed. We have a robocall mitigation plan and we're doing shaken. Well, I don't think they're really doing shaken because those calls aren't being signed with their signature. They're being signed with the signature of their intermediate provider. They're commingled with lots of other calls on the wholesale network, and it's hard to track them down. It makes enforcement difficult. So I think this is an indicator we're not near saturation. There are a lot of folks, and I've got friends, they haven't implemented shaken yet. They mean to. I'm like, hey, you got to do this. They're our customers. I tell them, you've got to do this. And they're like, we're going to do it. We're going to do it. They're late to the game. So it's, these people aren't robocalls. They're just slack. But there are folks that are trying to shirk the rules, and there are some laggards. But we're a long way from saturation is our point of view.
No, it's good. It's good. Yeah, if we can go on to the next. And then, this is the question, how many, the calls that actually get to the destination are actually signed, and then what percentage of them are signed? And as you can see here, the vast majority of the calls that actually get to the destination are still unsigned, and you kind of scratch your head and say, wait a second here, how does that happen? And I think generally the consensus is that the intermediate providers are dropping the shaken tokens, right?
Yeah, Alan, I think you're absolutely right. So just think about that. Shaken's been required by the big operators, in 2021. We got at least 400 companies who are implementing shaken. They may be intermediate providers. But look at how few signed calls are reaching our customers. Now, granted, we don't have 100% of the market, but we got a lot of endpoints on the network that are people are validating or verifying their phone calls. 73%, are showing up unsigned. What's going on there? And what we have seen anecdotally, because there's no hard data on this, but anecdotally again and again and again, we have customers. They're service providers. They're all SIP. They make a telephone call. They implement shaken. They make a telephone call, and they call their wireless handset, whatever it might be. There are only so many wireless operators in the U.S., and that call does not show up verified. It gets dropped between their network. They're buying, they're putting calls out into, to their wholesale provider. It could be multiple providers, but it doesn't make it to the end telephone. And when they dig into it, they find out with their provider, why isn't my call being verified at the far end? They find out, well, there's a TDM link somewhere in the call path. And that is really, that's, I think, for sure the main reason that so many calls are not signed that we see. Granted, this is our data, and I think if TNS presents some data that's similar and they have a lower number, I think about 50% of the calls that they see on their network are verified, but still, that's a massive number of calls that are not being signed. And the reason is, is we're hear anecdotally so many times that we feel highly confident in it is because they're being dropped by TDM networks, which is, leads to a really kind of an interesting situation because the FCC is looking at this data, not our data, but everybody's data, and realizing, their own handsets, I'm still getting robocalls that aren't signed, what's going on. They just closed a notice of inquiry asking the question, the TRACE Act required call authentication for non-IP networks. Is it time to require call authentication in non-IP networks? They're getting ready to implement that next phase. I think they're getting ready to implement the next phase of the TRACE Act where every network operator has to implement call authentication. And when the FCC first passed the rules addressing authentication for non-IP networks, they told the industry, you get an extension, you get a pass on implementing shaken for non-IP networks as long as the industry is working on a solution. And since that time, the industry's come up with two standards for shaken over TDM. One uses an out-of-band method. It's been around for a long time. We've been using it since 2019. It's part of an early IETF standard. And there was also an additional standard creating that actually takes that digital signature in the passport and squashes it down small enough to fit into an ISIP IAM message. So there are two standards-based solutions out there, and there are market solutions available. So we think, it's quite possible that the FCC may pass a rule in the near future that requires all service providers in the U.S. to implement shaken, using whatever mechanism you want. I wouldn't expect them to mandate a technology, but I think they may be at the point where they say no more extensions for non-IP networks. You've got a choice. You can switch to IP, or you can use some other non-IP mechanism for shaken call authentication using one of these standards. So anyway, this is really the big driver. We're still getting robocalls. And until, you got a bucket that's got a hole in it, it's just not going to work. You have to plug all the holes. And when this gets close to 100%, that's really the vision that we're all really excited about because that changes everything. Because, we're old enough to remember, like, when a telephone call really mattered, and now it's just like an annoyance. But you think about communication channels. Is there any communication channel that you can really trust? It's not email, text. You can't even trust video communications. When you get a Zoom call with somebody you don't know, you've got speaker recognition for audio calls, you've got visual recognition for video calls, but what if you haven't met that person? Or now in the world of deep fake videos, you really can't even trust videos probably in a few years. But what's so powerful about shaken is it puts in the infrastructure of the signaling network accountability and trust. No other communications network has that. And, it does take getting the feds involved because you need somebody there that kind of makes everybody accountable and can basically pull the plug on a bad actor and put them out of business. And that's what this infrastructure, the shaken governance authority, enables with a policy administrator. So anyway, getting a little bit ahead of ourselves, but I guess, why are we doing this? So much trouble. It's so frustrating. It's not even close to working. But, I guess hang in there because this future where you take this really important security infrastructure capability, and it's available to everybody, and for innovators to use, to come up with new applications that, we really don't know of today because we're just trying to make a lousy phone call work with a telephone number you can trust, it'll be worth it, and it'll be very exciting. And we're probably a few years away. But anyway, I didn't mean I kind of digressed a little bit there, Alan. Sorry about that.
No, it's okay. I'll kick you off your soapbox. All right, what's next here? All right, so a couple things here. First of all, just to kind of wrap up here with, stir shaken, what does it do? I think we've talked about, it secures that caller information. The original service provider, right, has permission to use the number. It defines these levels of attestation, which Jim did a great job explaining. It tells the subscriber, it passes along that it has attestation, and it provides an excellent traceback mechanism. And if you give me another click, but it doesn't do a bunch of other things too. It doesn't pass the level of attestation to the called party, at least in the current situation. So you get a call, you know it's verified, but you don't know is it an A, B, or C. It doesn't monitor the patterns of call abuse at all. It's not responsible for deciding this is a good call or bad call. It just lets you know whether or not the caller ID has been manipulated. It doesn't know the intent of the caller. They're trying to scam you. It just lets you know that school's closed today. It doesn't know how to differentiate between the legitimate and fraudulent behavior. It doesn't redirect any of the suspicious behavior, and it doesn't terminate the fraudulent calls. So those are other pieces of the part of the solution that are outside the scope of STIR/SHAKEN. So that's important to understand. Sometimes people confuse and they think that STIR/SHAKEN is responsible for squashing all robocalls, but it's only a piece of the puzzle. So we'd advance. So anyway, so we like to talk about there's this layered approach to stopping the illegal robocalls. It's kind of like stacks of Swiss cheese, if you can kind of think of it. If you give me a click. So a robocaller makes a call. This first step is this know your customer, right? We talked a little bit about the originating service provider needs to know who this customer is, and some are very good at it, and some are very lax. If you give me another click. So you can block that call if you don't know who the customer is or it's suspicious that the originating service provider. Give me another click. Or let's say you do know that originating service provider, and that's going to get all the way through. Because the originating service provider knows that customer, they're going to get through the STIR/SHAKEN, but at the far end, maybe the analytics would stop the call. And that's the destination service provider who's probably going to end up having to do that. And then the third one is that, here's a call, the customer, STIR/SHAKEN transports it, and then the analytics let it pass, and it eventually gets through to the destination phone. So this layering kind of approach, right? A lot of security has this layering approach, is what's necessary. Give me another click. Okay. So we already talked about this triennial report on the efficiency. It's hard for me to say. That the general agreement is that it's meeting its objectives, but it's only part of the puzzle. And since we already talked about that, let's skip ahead a little bit. I got one little story I want to tell you. So here's a real world story. We belong to the Cloud Communications Alliance. It's an industry organization. About a year and a half ago, at the tail end of the pandemic, we had one of these WebEx meetings, and one of the service providers piped up to talk about their own situation. They asked that their name be kept confidential because it's kind of embarrassing. And it goes like this. So they're an IP-based service provider. They got a new customer. They called up and said, I need 100 DID numbers on a SIP trunk. They accepted a check as a deposit and activated the trunks so that the trunks, with SIP trunk, they turn them on literally in seconds, right? So because that service provider knew who the customer was, they gave an A attestation, and the customer then started making calls. And all of a sudden, 1 month later, the wholesale operator shuts down the numbers. And they were like, what's the problem here? We got too many complaints about illegal calling on these numbers. So the service provider says, wait a second here. So I'm going to call the originating customer and say, what's going on? They try to reach out to the customer, and the customer says, what are you talking about? We didn't order any phone numbers. So all of a sudden, uh-oh. Well, it turns out that the offender here had stolen the identity of a company in New Jersey area, and was using that identity to get these telephone numbers, beat on them for over a month, with probably millions of telephone calls. And it wasn't until the wholesale operator stopped it because of their analytics that they were able to prevent any more traffic from getting through. And the worst part is the check bounced. So the check was fake. And it turns out that provider now is stuck with a black mark on their record from that wholesale provider. And it's, through this robocall mitigation, they've been having trouble with trying to do redress with many of their other service providers. So this is an example of one of the big problems, which is, you can lock up the front door, the side door, and you can put a decent deadbolt on the side door, but if you leave even the garage window open, they're going to get in. So if we go to the next slide. So what can we do? So a couple things we just want to leave you with. Number one, we think across the industry, at least we at TelcoBridges, and I think Jim, you share this, that we think it's super important that the know your customer be implemented industry-wide. that this is going to be mirrored much like the financial industry did in the 80s. Remember all the money laundering used to happen? We got to close those loopholes. We have to help the rural and TDM operators implement stir shaken and close the last few holes, or as your metaphor was, patch the holes in the bucket. And then last, to get serious about illegal robocall mitigation, right? Data sharing, big cloud databases so that we can squash this, because no one service provider necessarily has the data to know where this stuff's coming from, but from shared data and AI, you can quickly figure out where the illegal traffic is. So we'll call this the call to action slide. So if you're a service provider, give this some serious things. So a couple things where to learn more. I think go ahead and click. So Jim and I, our two companies, put together this little white paper. We're going to leave this slide up for the rest of you. It basically covers some of what we talked about today, but if you get that QR code on your phone, you can download a copy of that paper, and it basically gets into a little bit more detail with some of the features and functions we implemented. We're going to have a handful of copies of it down in our booth. We're at 453, and I think you're next door. So come find us on the show floor. We'd love to talk to you more about this, and I think we're almost out of time. 3 minutes to go, right? All right, so maybe open up for questions? Yes, Mark.
So on the previous slide where you said that your customer implement a strategy, is that up to the MSP to implement the strategy? Or is
That's a good question. Does the MSP need to know, right? Or who's doing the attestation? Because that's the person who needs to know the customer. That's the tough part. Yeah.
Right. Well, like your example of the fraud, they
Yeah.
thought they did the customer, right?
Yep. They thought they did, right. Now, the question, I will tell you though, in that example I gave you, the anecdotal story, they check a lot harder now that they've had this happen to them than they used to, Maybe they let the check clear, or maybe they do a D&B on the organization, make sure it actually exists. So, yeah. Yep. Yeah, question.
You explained, do you think that B attestation and C attestation are two really important?
Yeah, the B and C, yeah. What are your thoughts on the B and C too liberal?
C, it makes sense. You don't trust the number at all. It's called basically gateway attestation. At least you know where that call entered the network. So I think that makes total sense. I think something between C and A is provides some information. So I think B does make sense. I don't know. I think it's a good plan that's built into the standard. There was a lot of deliberation about what those attestation levels should be. What really matters is you need to get all your calls to attestation A. I mean, that is really the point of the trace stack. That's the point of the FCC rules. You need to know your customer and, police your network. And you shouldn't be taking calls from anybody. I was talking to a customer this week, and we were kind of sharing vetting rules about, what he does. And, we see a lot of these folks, and you probably do as well. It's a U.S. telephone number, and they've got an address in Delaware. But, everybody is obviously not from the U.S. And so he's like, what he asked for, we don't do this, but I'm thinking maybe we should. He's asking for articles of incorporation, and, who signed those articles of incorporation. He's asked for passport copies. And I thought, never thought of that. But, I guess that should have been obvious. But that's, he's primarily an intermediate provider, but he is concerned about the FCC's rules and trying to stay in compliance. And that's what he's doing to know his customers and to make sure, because he doesn't want to be that intermediate provider that puts, robocalls on the network, because there's going to be accountability. The FCC is going to go after certainly the gateway provider. If you're the gateway provider, why are you letting these calls into the U.S. network?
But one day, like a chain of one more provider talking to another provider talking to another provider somewhere, and if everyone does just B attestation, isn't there like a room for error?
No, there should just be one attestation, and that's who originates the call, and after that, the signature and the attestation should never be changed. But if you're a gateway provider, you're the first U.S. provider, maybe it's come from who knows where, you need to put a shaken passport on that call.
Yep. Good. Time for one more. Go ahead.
How does stir shaken account for call forwarding? For example, you're calling into a number and that number dialing into another number. How does stir shaken account?
Yeah, so I'm just going to repeat the question. So how does stir shaken handle when a number is forwarded from one number to another? Got any thoughts on that?
Yeah, oh yeah. Yeah, that's a really great question. So, forwarded calls, and that's a big fraud problem. I mean, I'm sure probably people have had that situation where unconditional call forwarding's been turned on, at least for toll fraud. But for, the more common case is people have their hosted PBX number forwarded to their cell phone. And they want to know, the person who tried to call me at my desk phone, it got forwarded to my cell phone. Is it a verified call? Well, you can't tell with a shaken passport, because when the call comes from the calling party's network to, let's say, the hosted VoIP provider, it's signed. You've got a passport that has the original calling number and the call-ed number, and it's signed by the originating service provider. But now it gets forwarded, and you forward that passport, it won't work for the forwarded call, because now you have a different telephone number as the calling number. You have the diversion number. So what the standards have, the solution that's been defined in the standards is you create a diversion passport. And a diversion passport is signed by the service provider who forwards the call to the terminating network. And the diversion passport includes the originating calling number, the call-ed number, the forwarded call-ed number, and the diversion number. And now you forward that call with two passports, the original base shaken passport and now a diversion passport. Great solution, but no one has implemented it. And what we've heard, in the standards meetings from, the big operators, we're never going to implement that until there's a mandate. And so there's really, the best you're going to get on a forwarded call, your hosted VoIP provider, you could sign that call. You could verify the passport you got, and if it's a attestation, you could trust it and now put your signature on it and forward the call with a base passport. Could, I don't know, or maybe you just send it with no passport. It's not a good situation. Not easy to implement diversion verification. It's certainly technically possible. Nobody wants to do it. It's time, money, and effort. I think it's going to take another mandate from the FCC to cause that to happen.
It's awesome. All right, we're out of time. I want to thank everyone for participating today. Great questions. Thank you very much for bringing them. And let's give Jim a little round of applause for helping out. Thank you.
And Alan, great slides. Thank you.